Alright guys, quick video lesson today. I'll give you guys time to work. Also give me a little bit of time to put some grades on the test for you. Okay, they've been marked, but I'll get you some grades, and that way we can start thinking about where we're at as far as overall grade for the semester. All you have left, assuming you've taken the test yesterday, all you have left is one more time on 7-3 next week. Okay, then plus any up to 2 reassessments if you want to redo up to 2 of them, if it makes an impact on your overall grade, obviously. Okay, we'll start figuring that stuff out here next couple of days. So today, learning target says I can change coordinates from polar to rectangular, okay, or rectangular to polar. All right. So keep in mind that a polar coordinate consists of what variables do we kind of use to represent the polar coordinates? R and theta. Very good. Okay, R and theta. And what does the R represent?
The radius from the origin. The distance from the origin.
Distance from the origin, the radius if you would draw a circle. Okay. Good. How about theta?
The angle.
Angle.
From the x-axis.
From the positive x-axis. So here's 0 degrees. Anything in this direction would be a positive angle. Anything starting this way would be a negative angle, just like we've kind of been working with all semester in trig. Okay? Rectangular, also sometimes called Cartesian, coordinates are just simply what?
X, Y.
X and Y. We're going to be able to take a rectangular coordinate and change it to a polar coordinate, or take a polar coordinate and change it to a rectangular coordinate. It's fairly simple, okay? Let's go ahead and let's do an example here. Let's change, somebody give me a polar coordinate, and you can use degrees, that's fine. Anybody? 6 to 10, first thing I heard, all right? 6, 210 degrees. Okay, and that is an R and a theta, and we're going to change it to rectangular. Okay. Anybody visually see how to do it already?
Either draw it out. Man.
Draw it out. Yep. So what do you think I'm going to draw?
Draw out the. Draw angle in the third quadrant.
Yeah, you could draw all the circles to get out to the 6th one, but in the end, how far is the point going to be away from the origin? 6 units. So what I'll do, I kind of like Dakota's idea here. All right, I'll draw my axes. He knows 210 would be in the 3rd quadrant, so I'm going to draw an angle out here to the 3rd quadrant.
6.
Okay, and what do I know about the length of this right here?
6.
It'd be 6. Okay? What do I know? What does the 210 tell me?
It's 30.
210 degrees from here all the way to here. So that would leave 30 left right there, correct? Knowing that information, couldn't you figure out the x and the y value pretty easily? That's all you need to do. How are you going to figure out the x and the y values?
Inverse.
Shouldn't have to do it in any inverse, because remember, when you use inverse, you're trying to solve for an angle.
So you do 6.
Cosine 30 equals x over 6. That would work to help you solve for x. The cosine of 30 equals x over 6.
Sine of 30 equals y over 6.
Sine of 30 equals y over 6. What mode would your calculator want to be in?
Degree.
Degree mode. Is your calculator going to give you a positive or a negative value for x and y?
It's going to be negative.
What's the calculator going to give you? Calculator will give you positive because you're using just a reference angle, the 30-degree angle, and those are any reference angle is always between 0 and 90. So it's just going to give you a positive, but what should the x and y values actually be?
Negative.
Both of them should be negative.
So if you said cosine 210, it would be negative. Thank you, sine.
Yes. Yes. Yeah. If you would actually use the angle they give you, then you wouldn't have to worry about changing them to positives and negatives. Okay? So you guys kind of have an idea how to do them already. Would you agree with me that x equals r times the cosine of theta? That's kind of where Derek was going. The x value ends up equaling the r value times the cosine of theta. You guys see that? That's what you're really doing here. Okay? And what does y equal then? R times the sine of theta. Okay? So, if you're kind of a formula person, and just want to use these formulas, you're certainly welcome to, but you're going to end up doing things we've already done in trigonometry before, if you just draw the picture. Okay? Now, did anybody think of the 30, 60, 90 triangle and just get their answers that way, and then they didn't even have to get out a calculator? I got your guys' brains hooked into those 30, 60, 90s yet?
X square root.
You got x root 3 and 2x.
Yeah.
Yep. The side across from the 30 is always half of the hypotenuse. So I know my y value is going to be 3, or negative 3 actually. And then the side across from the 60 is always the short leg times root 3. So if this is 3 over here, that's 3 root 3. So your final answer would be negative 3 root 3, negative 3. Okay. Negative 3 root 3, negative 3. Okay. That would be exact. You probably had a decimal for x, correct? Those of you that were doing it on your calculator.
Isn't this kind of like polar, or not polar, but like vectors and stuff?
Yeah. It's all really related. Mm-hmm. Very much so.
Well, didn't we do all this stuff already in vectors and stuff?
Yeah, pretty much in a sense. I'm just relating it to polar forms.
Oh.
Yeah, no, you're right on. It's just now we're talking about polar form instead of forces acting like a vector does. Yeah, that's good, Dakota. Okay? So, changing from polar to rectangular. Draw pictures, set up your equations. Or, if you just want to memorize those equations, you're welcome to memorize those. Both will work. Any questions on that? These are your x and y values. That is your answer. Okay? And the way around's pretty easy. Put or negative 3 in polar coordinates. Okay? So what do you do here?
Draw a picture.
Yeah, why not? Right? Draw a picture. Or negative 3.
Find the hypotenuse.
Find the hypotenuse, because that is your r value, correct?
So it'd be 5.
Yeah.
Yep, r would be 5.
And then you use inverse sine.
Inverse
Sine.
Inverse sine of what?
Negative 3 over 5.
Negative 3/5, that would work. Could use inverse tangent.
Yeah.
Inverse tangent of negative 3/4. Inverse cosine of 4/5. Okay? Formula-wise, what does r equal? Square root of what? Make it generic. Make it true for all, not just specifically for a
X
negative 3.
squared plus 1 squared.
That make sense?
Yeah.
Okay. You take x squared plus y squared, and then you square root that answer. Won't that equal what r is? That's Pythagorean's theorem. Because isn't x squared plus y squared going to equal r squared? Okay, so r is equal to the square root of x squared plus y squared. And theta, in terms of x and y, how would you find theta if you knew what x and y were?
Inverse something.
If we only knew what x and y were.
Tangent.
Inverse tangent of,
X over y over x.
good, y over x. Inverse tangent of y over x. Okay? So, plug 4 in for x, plug -3 in for y. We know that r would end up equaling 5. Theta equals the inverse tangent of -3 over 4. And in degrees, what'd you guys get? To the nearest tenth. Inverse tangent of -3 over 4. 36.8. You get a second on that anywhere? Okay, there it is. But let's put it correctly. So let's write it as a polar coordinate. What would it be?
Yeah, you are.
5, comma, 36.
Dakota, come on.
Oh.
Negative.
Oh yeah, negative.
5 comma negative 36.8 would work. Because remember, this is 0 degrees straight out here, right? If we said 5 comma 36.8 degrees, wouldn't that be a coordinate that's up here somewhere? Positive 30? Okay? So you'd say negative 36.8. What else could you say?
Did you say
39.3.2.
Okay, 360 minus that, right?
Yeah, 3.3.
Okay, both would work. That'd be in degrees. So 5 comma negative 36.8. So fairly simple. Changing forms. Okay, a little bit of practice here. Page 572, 14 through 25. Page 572, 14 through 25.